All right, welcome to the video for the Semester 2 review on our standard 6312, which is calculating perimeter area, surface area, and volume of 2 and 3-dimensional figures to solve in real world and mathematical problems. Let's take a look at our first problem. Pablo is carpeting his rectangular living room. The length of his living room is 14 feet and the width is 18 feet. How many square feet of carpet does Pablo need to buy? So the first thing we need to figure out is what shape this is, what quadrilateral. So I'm going to go ahead and underline. It tells me that it's a rectangle. So the first step is I'm going to draw a rectangle so that I visually have something to look at. Now we need to look back at the problem and figure out what is it that we're trying to solve, and that is how many square feet of carpet does he need to buy. So square feet tells me that I'm looking for the area of his carpet, which is a rectangle. So our next step is to figure out what formula we're going to use to find the area of a rectangle. So your formulas are here. These are the formulas given on your formula sheet. And this is the formula that we need. Area of a rectangle or a square equals the base times the height. So in order to find the area, we're going to need to know what the base and the height are. So let's go back to the problem. The length of the living room is 14 feet. So I'm going to go ahead and label the length 14 feet. And the width is 18 feet. So we're going to label the other side 18 feet. So now we're going to go ahead and just follow the formula. And I'm going to substitute and solve. So base times height equals the area. Our base is 14 times our height is 18. And then we're going to go ahead and solve that. And then if I work that out, I get a total of 252. So the area of this rectangle is 252, but we need to label that square feet. So feet squared. And what that means is that there's 252 little squares like this. That's 1 foot by 1 foot to fill the area of his carpet. So that is number 1. All right, let's take a look at number 2. What is the area of the parallelogram shown below? Again, our first step is to look at what shape, what polygon are we trying to find the area for, and decide what formula to use. And if I look at these formulas, again, we're going to use the same formulas we did for the rectangle. Our formula for a parallelogram is area equals base times height. The reason it's the same as for a rectangle is if you went straight down here and made this a rectangle and cut this off, you'll notice that you can cut this sliver off and it will go right over here. So it looks just like a rectangle would if you just cut a piece and move it. So we're going to use that formula. I always like to write down the formula that I'm using and then substitute and solve underneath and then figure it out. So we need to know the base and the height. So I can see the base right here of my parallelogram. That's that bottom edge is 4. So I'm going to put 4 down there. Remember, 2 letters next to each other means we're going to multiply. And now you can see that we need to know the height. So height is always perpendicular to the base. It makes a right angle. So our height is this right here. It is not this side edge. It is straight down from the ground up to the sky. Again, perpendicular to the base. So our height is 5. So to calculate our area, we're just going to take 4, multiply it by 5, and get 20. Let's go back and look at our labels. That is centimeters squared for the area of this parallelogram. All right, so number 3, find the area of the trapezoid shown below. So we're being told what quadrilateral this is, and it's a trapezoid, and the area. Now let's review really quick what the definition for a trapezoid is so you know when to recognize it. This one is kind of a different looking trapezoid. I know that you're used to seeing something a little bit more like that. But the definition of a trapezoid is that number 1, it's a quadrilateral, so it has 4 sides. And then number 2, one set of lines are parallel. And we'll use this as a diagram for parallel. So unlike a parallelogram where both sets of opposite sides are parallel, in a trapezoid only one. So you can see this does have 4 sides, and you can see that one set of opposite lines, that's these two, are parallel to each other, and these two are not. So that makes this a trapezoid. So since it is a trapezoid, we are going to use this formula right here. Area equals 1/2 the height times base 1 plus base 2. Now remember the bases are always parallel to one another in a polygon or in a 3D figure as well when you're trying to find like the surface area. Bases are parallel. So let's go ahead and write this formula. Area equals 1/2 times height. You should be copying this on your notes times base 1 plus base 2. So let's figure out what the height is, what base 1 is, base 2. We'll substitute and solve. All right, so we'll start with half. That stays the same. Half of the height. In order to figure out what the height is, let's figure out what the bases are first. So again, bases have to be parallel. So this line and this line are actually your bases. So it doesn't matter which is base 1 or base 2, but let's say 1/4 is base 1 plus 1/2 is base 2. Now the height always connects your two bases. So if these are our bases, then this is our height. So let's go ahead and label each of these numbers. So our height is actually 3/8. Now remember 1/2 h means that you're going to multiply that. So we have a little figuring to do with the fractions here, but we're going to use order of operations. So let's start by adding what's in the parentheses here. 1/4 plus 1/2. I'm going to show my work over here because I need to do what I know about adding fractions at this point. I know I need like denominators, so let's change 1/2 to 2/4. So now we have 1/4 plus 2/4 equals 3/4. So our two bases added together, go ahead and caret it down, and we're going to make that 3/4. Then the next thing we need to do is we need to multiply in the order we see it. So we see 1/2 times 3/8 first, and then we're going to take that times what's in the parentheses. So I'm going to go ahead and give myself a little bit more space here. And I need to solve 1/2 times 3/8. So I'm just going to go to my scratch paper over here. 1/2 times 3/8. I'm going to write that horizontally. And remember, we just need to multiply our numerators and multiply our denominators. So 1 times 3 is 3. 2 times 8 is 16. I cannot simplify that anymore, so let's go ahead and bring it up here and see what we're left with. So the area of our trapezoid equals 3/16. That's this multiplication problem. Times, because when a number is outside the parentheses, we need to multiply, times our 3/4. So we just have one more step. We're going to multiply these two together. So again, I'll go down to my scratch paper and I need to do 3/16 times 3/4. And again, multiply your numerators and we get 9. Your denominators and we get 64. All right, so we are left with 9/64 as our area. And I cannot simplify that. I can't divide 64 by 9 or by 3. So our final answer is going to be that the area of this trapezoid is 9/64. And we're going to say feet squared. And it's okay to work with fractions, and it's okay to have a fraction as an answer. All right, number 4. What we have is we're going to be finding the area of a composite figure. We have kind of an interesting figure here. It's not something that I can just plug into one of these formulas. So what we're going to do when we're trying to find the area of an irregular composite figure, we're going to cut it up into pieces that we do know. So when you're trying to solve something you don't know, use what you do know to help you figure that out. I can see that we can cut this into 2 rectangles. So I'm going to go ahead, and I think this will be helpful for a lot of you. Cut it on the figure, but then also let's just draw these 2 rectangles and separate them out. Then if we can find the area to each one of these separately, which I think will be easier for you to think about that way, then we would just add the area of these 2 pieces. So both of these, I've separated them out. They're both rectangles. So I'm going to use this formula for both. Area equals base times height. So by having them separated, we can see that in order to find the area, we need to know the base and we need to know the height. So let's go ahead and look at this first one and label. I can see, so this rectangle is right here, that the height of it is 6. So let's label it down here. And the base of it, the width of it here is 8. So if it's 8 up here, it's also 8 down here. If this is 6, this is also 6. So let's go ahead and substitute and solve. Area equals base times height. The base is 8 and the height is 6. So 8 times 6 is 48. So I'm going to go ahead and stick that right in here. And let's write it up here as well. So 48 yards squared is the area of this rectangle. All right, so we drew this rectangle right here. And what do we need to find? We need to find the base and the height. So let's see if we can do some problem solving to do that. Let's start with the base. That is right there for us. So we'll put down 2 yards is our base. And now let's figure out the height. So the height of this is from here all the way to here. So what do we know? Well, I know that this portion is 2 yards, and I know that from here to here is 6 yards. So if we bring that over, that means here to here is 6, and here to here is 2. So even though they don't tell us the height here, we're going to use our problem solving and just say, well, if this is 6 and this is 2, add those two together. This whole height over here has to be 8 yards. So again, I will label this 8, and over here I can show that as 2 plus 6 is 8. Let's substitute and solve. The base was 2 times the height is 8, and we get 16. So I'm going to erase some of this extra stuff that's in my way for a moment. So I'm going to put the area inside here is 16 yards squared. Now, if I'm adding two pieces together, I want the area of all of it, then all I need to do is add those. So 48 plus 16, and I come up with a total of 64. Don't forget to label that yards squared or square yards. So again, with composite figures, cut it up into figures you know. Draw each of your pieces separately. Find the base and height of each one and the area of each one, and then just add them together. All right, for number 5, find the area of the kite shown below. Now, what people find tricky about the kites is that we don't have just a good set formula. We could come up with one, but it'd probably be more confusing than just breaking it down like we're going to do right now. So none of these fit exactly, but we can treat this as we did in the last problem, a composite figure. So what I'm actually going to do is I'm going to recognize that this is two congruent triangles. So I'm going to break these two triangles apart first and see that here the top is one triangle and the bottom is one triangle. And they are congruent, they are the same. So if I can find the area for one of them, then I can simply multiply that by 2. Now we have to be careful because you get different information. You need to make sure that you're using the right numbers. So since I'm working with two triangles, this is the formula that I'm going to need to use. The formula for the area of a triangle is 1/2 base times height. So we need to be able to find the base and the height of this triangle so that we can take half of it and find the area. And then once I know the area for one, that's the area for the other, and I will just add those together. So let's take a look at this rectangle or this triangle. We need to know the base. Well, that's going to be this line right here is the base. Well, if I look up here, I can see that this part of it is 4 meters and this part is 9 meters. But what I need to know is what is the base all the way across. So we're going to add those two together. So 4 plus 9 is 13. Let's write our formula down here so we can substitute and solve. Remember, area is 1/2 base times height. So the base is 13. And then the height, remember, is always perpendicular or a right angle with the base. So even though this kite is 6 all the way across, if I take half of that, the height of just one of the triangles is just this part. So if you're given the length all the way across the kite, if you want to find the height of just the triangle, make sure you take half of it. So the height of just one triangle is 3 meters, which you can see right here. So the base of this triangle is 13, the height is 3. So we're going to go ahead and multiply those two together. 13 times 9 is 39. But don't forget we have to take half of this. And that is the biggest mistake that people make with triangles is they just forget. So if I want the area of 1/2 of that kite, or of the triangle that makes up the kite, we're going to take half of 39, which remember is just 39 divided by 2, and get 19.5 meters squared. So if I go back up to my kite and I could highlight what it is that I just found the area of. Okay, we just found the area of just half of this, of just that triangle. By again taking the base of 13 times the height of 3 and then dividing that by 2. So let's put the area in this as 19.5 meters squared. And that means that the other half, which I will color a different color, this triangle right here, since they are congruent, they are equal, this is also having an area of 19.5. So if I want to find the area of the whole kite, I'm simply going to add that together or multiply by 2. So 19.5 plus 19.5 actually gets us back to 39 meters squared. So there's a lot of ways to look at a kite and think about it, but what I would really recommend to you when you solve these is just draw them as two separate triangles, find the area of each one of both pieces, and then simply add those back together. Just be careful that you're finding the base of that triangle and the height of just the triangle and not the whole kite. All right, here is our last problem. This problem says the area of the trapezoid shown below is 42 square units. What is the height? So this is an interesting one. Instead of finding the area, we're finding a missing height. So let's look at what we know. Again, we're looking for area. Our polygon is a trapezoid, and our area is 42. It's always good to underline keywords and make some notes for yourself. So our first step is to decide what formula do we need to use. This is a trapezoid, and as we've already talked about earlier, this is our formula for a trapezoid. So I'm going to go ahead and rewrite that myself so I can substitute and solve. So remember what this means, 1/2 of the height times base 1 plus base 2. So what I like to do is add my bases, find half the height, and multiply. But again, this time we're given the area. So I'm going to substitute for area 42. And I know that I want 1/2 of the height. Let's take a look at our trapezoid. And that is our variable, that is our unknown. So we're going to have to keep our height with that letter H for now. Then instead of base 1 is 9, base 2 is 5. So let's figure out what we do know here. I can add my parentheses together, so let's do that first. Our bases added together is 14. So we know that if we take half of the height times 14, that needs to be equal to 42. So what we actually have here is we have an equation. You could do this a couple different ways. You could solve it as a two-step equation. You could also try a little guess and check. Let's try it both routes here. So first of all, I could look at it as a two-step equation. I want to get h by itself so that I know what the height equals. So remember, I'm going to do the opposite. I've got h times 14, so let's do the opposite of times 14, and we'll divide this half by 14. So I need to divide the other side by 14 as well. And 42 divided by 14, we end up with 3. So here's what we're left with. 3 is equal to half of the height. So all we're really asking is half of what number is equal to 3. And here's where you can just use common sense and say half of 6 is equal to 3. So our height must be 6. Let's substitute and solve and see if that works. So if we go back to our original formula, half of 6, if we say that 6 is our height, half of 6 is 3 times, add our two bases, base 1 and base 2, 9 plus 5 is 14. And let's see if 3 times 14 does actually equal our area of 42. And if I work that out, it absolutely does. So 42 is equal to 42. So I can see that our height is in fact 6. Now, if you wanted to try a little bit more, just guess and check, you could try half of different numbers. Half of 4 would be 2. 2 times 14 is too small. Half of 6, and then get 3, 3 times 14, and you'd see that that works. So if you're not comfortable with using the equations, then go ahead and try some different numbers. Try some guess and check. You can see that this is 9 and this is 5. You can see that these two are going to be pretty similar. That's not always, you can't always eyeball it, but sometimes that will work. So it will give you at least an estimate to start with. So if you feel more comfortable setting up your formula and just guessing and checking, then go ahead and do that route too. But always just check. Check your answer and see if it works for you. All right, good luck with this. Make sure that you've fixed everything with the video and you should do well.